Good morning. Sorry that I couldn't be here with you guys today, but hopefully, if you watch this short video about polynomial functions and factoring, you'll be okay. We're going to do a couple of examples together. First, I wanted to talk about the warm-up a little bit, make sure everybody understands the warm-up because we've got a picture here. It's just a hand-drawn picture, and yours might look slightly different, but I drew it in. Oh, there's the bell. Okay. Hope everybody's in their seats. I drew my picture a little bit different on the board, and we're going to go through and talk about the domain and range and all of that stuff. So the domain for this function is all real numbers. So if you want to put that in interval notation, I just want to make sure you guys have these. It's from negative infinity to infinity. Oh, this is hard because I can't make a mistake because no one can point it out to me. And then your range is also all real numbers because it goes from negative infinity all the way up to infinity. So we'll say y such that negative infinity is less than y is less than infinity. And that's set notation. This is a good review because we haven't done these in a while. Okay, now for interval of increase and decrease, I probably need to get some highlighters out here. When you do your interval of increase and decrease, remember that increase means if it's on a roller coaster going left to right, it's the uphill portions. So I'm trying to describe this part and this part of the graph because those are both going up. Whereas the decrease, well, we'll go back and do the decrease in a second. Let's just focus on the highlighted portions right now. When I do the increasing portions, I'm only talking about them in terms of x. So it's everything from negative infinity to right here. This maximum point here is at x equals -3. So I'm going to say from negative infinity to -3. That's the first one. And then the second one is from 2 to infinity. That's the second highlighted portion because we only talk about them in terms of x. So if it's helpful like to label these points like this, you know, because that helps you to put your eyes on the x values, that we're only thinking about the x values when we do intervals of increase and decrease. That might be helpful to you. Okay, and then my decreasing interval is here in the middle. It's the part, I'll do that in green. The decreasing interval is the downhill portion of the graph. And again, I have to think about the x values. So it's between -3 and 2. That interval. And I'm using these open brackets here because I don't want to include the turning points as part of the intervals of increase and decrease. Speaking of turning points, there's 2. The y-intercept is at 0, -3. And the solutions, again, I'm trying to use all these words interchangeably. Solutions just means x-intercepts, which are at -5, -1, and looks like 4. -5, -1, 4. Solutions are x-intercepts, so I'm just listing those off. Now my end behavior, we've been talking about that in terms of rises left and falls right, but now we can also talk about it as we did before. As x approaches infinity, so I'm looking on, let me get a different color so you can see where I'm looking. As x approaches infinity, now I'm over here, I'm looking at what's happening to the graph. The graph is going up towards infinity. Okay, and as x approaches negative infinity, I'm looking on the other side of the graph. Let me go purple. As x approaches negative infinity, I'm going this way. Then f of x, y, is approaching negative infinity. Okay, so that's our warm-up. We're going to do 2 things today. We're going to take a look at the new topic, and then we're also going to go back to those last 3 homework problems from homework 1 and how to do the factoring the sum and difference of cubes. Okay, so if you remember last time, I do want you guys to write this stuff down just as you would if I were standing in front of you at the board. You would be writing this down. So you should be writing this down now on a separate sheet of paper. And we're going to do, as I said, we're going to do just a couple of examples. And this time, what's different is instead of starting you off in factored form, I'm starting you off in standard form. Okay, so that's a standard form equation. Now, notice it doesn't have a constant term. That's okay. So when I'm looking at this in standard form, and just like last time, we're trying to make a graph of this. I'm probably going to first be thinking, when I look at the standard form, about the end behavior. Okay, and this is my end behavior. Rises left, falls right. I can figure that out from the degree of 3 and the leading coefficient of -2. And I also know my y-intercept. Notice there's no constant term. So if you plug in 0 for x, you're going to get 0 for y. So my y-intercept is at 0, 0. So I can go ahead, it's also an x-intercept, and I can put that on the graph. Okay, now in order to figure out what the zeros are, what the roots are, I have to factor this. I need to put it in factored form. Well, if you remember back to quadratics, the very first thing we always did with quadratics was to try to look for a GCF and factor out a GCF. So I'm going to do that here. I'm just recopying the equation first. Okay, so I'm looking at these three terms in this trinomial, and I'm asking, what do these have in common? Well, they all have a -2, and they all have at least one x. So I can bring that out to the front. Now when I do, what's left behind here is x squared plus 5x, bringing that out, plus 6, right? Now I always go back and check my factoring by like at least foiling this in my mind. -2x times x squared, that works. And I'm just foiling this in my head to make sure I did it correctly. Not foiling it, distributing it. There's f of x. And now, once I've pulled out the GCF of -2x, I can factor this. It's x plus 2, x plus 3. And now I can make 3, just like we always did. To find the zeros, you set it equal to 0. You make y equal to 0. And I have 3 mini equations. -2x equals 0, x plus 2 equals 0, and x plus 3 equals 0. So my zeros are 0, -2, and -3. -3. So I can go over to my graph now. The first one I already had on because that was my intercept as well. And I can put on a couple more zeros here, -2 and -3. And now I can also go back and say, okay, I know the end behavior. Let me go ahead and put that on. Oops, I'll use red for my graph. From here, it has to go down. From here, it has to go up, right? Degree is 3, and I have 3 zeros, so I don't have any repeated roots. I don't have any bounces. And I'm going to go something like this just to kind of connect the dots. Okay. Now, before we were being a little bit vague about these peaks and these valleys. Like, we don't really know how low this valley goes unless we plug in a number, nor do we know how high this peak goes unless we plug in a number. But I do want to introduce to you today that these points have names, okay? This point at the top, this mountaintop, we call it a relative maximum. Okay, and this one's called a relative minimum. Okay, minimum. We also have, for every function, you also have absolute maximums and absolute minimums. Sometimes they're the same, but in this case, the absolute minimum of this graph is negative infinity, right? Because this just keeps on going down. And the absolute maximum is infinity because the graph just keeps on going up. So by relative, it means we're just looking at the middle portion of the graph. We're looking at the peaks and valleys in the middle of the graph. Of course, the value of this graph can go all the way down to negative infinity, but I want to figure out just what this point is. Now, we don't have the skills right now to figure that out algebraically. Later on when you're in calculus, you will be able to figure out exactly what the relative maximum and minimum are using algebra, doing it on paper. So for right now, what you're going to do is you're going to go grab a calculator, and you are going to put this function, this f of x function, in where it says y equals. And then you're going to take a look at the graph, okay? And now, if the window is not set appropriately, you can just go to Zoom Standard, and that will I think, set it back to like our normal screen. And just like we were earlier, we were finding the, calc max, right, when we were doing our word problems in the last unit. We're going to use that same calculator skill to help us figure out the relative maximum. And you can also calc min. You have to like set the boundaries, and you can figure out the relative max and the relative min. And when you do that on the calculator, this is what I got. I'm just going to round to the nearest hundredths place. It will give you a lot more values, of course. But you can get those values now off the calculator. Now what this means is that I might need to actually, yeah, the relative maximum is probably could be drawn a little bit higher. But you might want to adjust your drawing according to what the relative max and what the relative min are. Okay? All right, let's take a look at another one. Two more, actually. Come on, extend page. It's not working. Huh. That's strange. Okay, I'm going to go to a new sheet. Or am I? Let's see. No. Add a page. Come on.